Hello, these are the notes for section 6.1 and 6.2. Factoring quadratic expressions. Part 1, Common Factors. Pulling out a common factor is the simplest type of factoring and involves using the distributive property in reverse. For example, A times B plus A times C has an A in common, so I can factor the A out, and then we're left with B plus C in parentheses. Example 1. Pull out the largest common factor from each expression below. Part A. 4x squared minus 2x. The largest common factor that these two terms have is 2x. So I can pull a 2x out. And then we are left with 2x minus 1. Don't forget that it's going to be 1. The 2x just doesn't disappear. And you can see this if you think of factoring as division. So 2x divided by 2x is 1. So that's where the 1 is coming from. Part B, 12x to the fourth minus 4x cubed plus 16x squared. Well, here I know that they have 2x in common as well, so I can factor a 2x out. And then we're left with 6x cubed minus 2x squared plus 8x. But if I look at what's left over in the parentheses, I notice that they still have a 2x in common. So I can factor another 2x out. So we have this 2x stays, and then I factor another 2x out. What's going to happen is we need to multiply those together, and then we're left with 3x squared minus x plus 4. Now 3x squared minus x plus 4 have nothing else left in common, so I just have to go 2x times 2x is 4x squared. And then we get 3x squared minus x plus 4. What this is telling me is I could have factored a 4x squared in the first step, and then this would have been a one-step problem instead of a two-step problem. I just did it as a two-step problem for teaching purposes. Now, part C, we have x squared times x minus 3 plus 4 times x minus 3. So because this is multiplication here, this is a single term. Even though it looks like 3 terms, because of the parentheses and multiplication, it is 1 term. Similarly, over here, because of the multiplication, this is 1 term. So we're only dealing with 2 terms here. What do these 2 terms have in common? They have an x minus 3 in common. So if I factor that x minus 3, then we're left with x squared plus 4. So the GCF need not be a monomial. The GCF could be a binomial or even a trinomial. Part 2, factor by grouping. Factor by grouping is the process of grouping, then pulling out common factors. Specifically, separate the terms into the sum of two groups, usually pairs, pull out a common factor from each group, one or both may be negative, and pull out a large common factor, a binomial, of the form ax plus or minus b. Factor by grouping is usually applied to an expression with 4 or sometimes 6 terms. Example 2. Factor each polynomial by factor by grouping. Part A. X to the fifth plus 2x cubed plus x squared plus 2. So I want to factor this by grouping. I'm going to split it down the middle. And the first two terms have an x cubed in common. So I can factor an x cubed out, and I'm left with x squared plus 2. The second two terms have nothing in common. When the two terms have nothing in common, you can still factor a 1 out, which is what I'm going to do. And I'm left with x squared plus 2. Now, this is the factor by grouping part that these two pieces have to match. If you can't get these two pieces to match, that just implies that it's not factorable. But in this case, they do match, so I can factor out the x squared plus 2. And we're left with x cubed plus 1. Part B, 2x cubed minus 6x squared minus 3x plus 9. So I'm going to split it down the middle and see what do the first two terms have in common. They have a 2x squared in common, and we're left with x minus 3. What do the second two terms have in common? Well, you might say they just have a 3 in common, but whenever you're factoring by grouping, whenever that first term is negative, you're going to factor that negative out as well. So instead of just factoring out a 3, I'm going to factor out a negative 3. And then it becomes x minus 3. The x minus 3's are in common now, and I get x minus 3 times 2x squared minus 3. And part B is done. Now for part C, x cubed plus 2x squared minus x minus 2. I'm going to do this a little bit differently. I'm going to swap the middle two terms. Now you don't have to do it, it'll work out if you don't, but I just wanted to show you an example of where we do it, because there are some times where you do need to swap the middle two terms in order for it to be factorable. So then it becomes x cubed minus x plus 2x squared minus 2, split it down the middle. What do the first two terms have in common? An x, and we're left with x squared minus 1. What do the second two terms have in common? A 2, and we're left with an x squared minus 1. And now the x squared minus 1's are in common. I can factor that out, and we get x squared minus 1 times x plus 2. And that's how we factor it by grouping. One thing I do want to mention, even though we haven't talked about it yet, we're going to talk about it in section 6.3, but this will just kind of foreshadow it. X squared minus 1 is factorable. X squared minus 1 is the same thing as x minus 1 times x plus 1. And to check the work, you could just distribute everything, and it'll come out to be x squared minus 1. So the fully factored form for part C is x minus 1 times x plus 1 times x plus 2. And that is it for the first part of section 6.1.